Laplace transform. What is Laplace transform? Laplace transform is a process which is used to transfer complex functions into simple algebraic forms. Sometimes we have very complex functions to solve. So what we do here, we use the Laplace transform process where we first transfer that function into algebraic forms because it is easy to solve them in algebraic form. So once we get the output of that functions, then we transfer that function back to their own original form. That's what Laplace transform do for us. It makes things easy for us and gives us a comfortable zone to do things in an easy way. Laplace transform is normally used to solve ordinary differential equations by transferring them into algebraic form, which is S-domain, to make it easy. As I said, Laplace transform is used to transfer the function from one form to another and then back to its original form. Normally it is used to solve ordinary differential equation, which is in calculus form. What happens here, sometimes these differential equations are very complex to solve. It's not very easy to solve. Therefore we transfer them into algebraic form, which is S-domain, because to solve that equation into algebraic form is easy compared to what we have in calculus form. So once we get the final result from that equation in algebraic form, then we transfer back that equation into calculus form, which is its original form. That's what Laplace transform do for us. It is very helpful at some stages where we have very complex functions to solve. Laplace transform are used in filter designing and analog circuits, which are represented by differential equation. In fact, Laplace transform has many applications in daily life. These are the two applications of Laplace transform: filter designing and analog circuits, which is represented by differential equation. The differential equations here are very complex because there are a lot of capacitors, resistors, and other components in that circuit to represent them into differential equation form. Now, to solve that differential equation is very hard. Therefore, we use Laplace transform here to transfer them into algebraic form first. Once we get the answer, then we transfer back that equations into their original forms. Mathematical representation of Laplace transform. How we can define Laplace transform in mathematical language. Let f of x be a function for x. Then the Laplace of f of x equals to integral of e to the minus sx times f of x dx. This is the basic definition of Laplace transform in mathematical form, or it is the basic formula of Laplace transform. But in some books they have written f of t. So it's one thing whether you take the function for x or for t, it's up to you. If you take the Laplace of f of t, it equals to integral of e to the minus st times f of t dt. It's just a matter of x and t. You replace x by t. So don't be confused here because some books have taken the function for x and some has taken the function for t. I repeat it here, mathematically we can define the Laplace transform in a such way that if f of x is the function for x, and when you take the Laplace of f of x, it equals to the integral of e to the minus sx times f of x dx with the limits from 0 to infinity. Don't forget the limits, it starts from 0 to infinity. But one thing you must keep in mind that this f of x must be a finite value. You can't put f of x an infinite value. F of x must be a finite value.